In this section, we're going to talk about number systems, but we're going to discuss them in a way you've likely never discussed them before. That's because in school, I'm sure you learned what they are, but I am almost certain you never learned why they are. This is the most important topic in this entire course. If you understand what we cover here, learning to code will follow naturally. That's because code is based on number systems. You'll see why and how when we connect the dots in a later section. Now, do not be discouraged if it doesn't make sense the first time around. Grab a cup of coffee, go for a walk, come back, and rewatch it. Try examples on your own, but do not move on until this material makes sense. We should all be familiar with the decimal system, numbers like 1 through 10. But I have a question. Why is it called the decimal system? It has something to do with the number 10, right? After all, decimal derives from the Latin root decimus, which means tenth, and decimus further derives from the Latin root decim, which means 10. We can deduce that it's a number system that is somehow based on the number 10. All we have to do now is figure out what that somehow is. Maybe it would help if we actually looked at a decimal number. So we have here the number 100. Let's go ahead and add to it the number 10, then the number 1 to get a sum of 111. Now, what is the rightmost digit of this number referred to? The ones place, correct? And the middle digit is referred to as the tens place and the left digit the hundreds place. So at this point we know two important things. We know that the decimal number system is somehow based on the number 10, and we know that the first digit of a decimal number is called the ones place, the second the tens place, and the third the hundreds place. So here's the million-dollar question. Why? Why is the first digit called the ones, the second the tens, the third the hundreds, and so on? Well, to answer this question, let's actually first answer a different question. What? As in, what is 1 in terms of 10? We might say, well, it's 10 minus 9, which also means it's 10 plus negative 9. Or it's 10 divided by 10, which also means it's 10 times 1/10. These all work, but we're missing one more. 1 is also 10 raised to the 0th power, correct? And if we continue on, what do we find? What is 10 in terms of 10? Well, it's 10 minus 0, which means it's 10 plus 0. Or it's 10 divided by 1, which means it's 10 times 1. Exponentially, check that out. It's 10 to the first power. The tens place is exactly 1 power higher, using 10 as our base, than the ones place. And by the way, that explains why the denominator of our division shrunk by an order of 10, while the factor of our multiplication grew by an order of 10. And look, 100 in terms of 10 is 10 to the second power. By answering what, we can now answer why. Why is it called the ones place? Because it represents 10 to the 0th power. It's called the tens place because it represents 10 to the first power. And it's called the hundreds place because it represents 10 to the second power. And when we look back at our number 111, we can identify something fascinating. Written another way, the number 111 is actually 1 times 10 to the second power plus 1 times 10 to the first power plus 1 times 10 to the 0th power. We can conclude then that a number system is a sequence of digits where each digit is multiplied by the base of the number system raised to a certain power. So when we speculated earlier that the decimal number system is a number system based on 10, it turns out we were exactly right. Although we can state it more succinctly by saying the decimal system is a base 10 number system. There's one final question we may have at this point, and that question is, why is the first digit 10 to the 0th power? Why isn't it 10 to the first power? Of course, it's because it's the ones place, and 10 to the first power is 10, not 1. 10 to the 0th power is 1. But that's actually a rather superficial answer. This question inspires a more fundamental one in number theory, which is, why is any number raised to the 0th power equal to 1? And the answer is that it has to be. When we divide 100 by 10, we get 10. In terms of exponents, this means that when we divide 10 to the second power by 10 to the first power, we get 10 to the first power. So we subtract the denominator's power from the numerator's power. That is, we subtract 1 from 2 to get 1. Now, what about when we divide 100 by 100? We get 1, right? In terms of exponents, this means that when we divide 10 to the second power by 10 to the second power, we get what? Well, the denominator's power is 2 and the numerator's power is 2, and using our rule of subtraction, we know that 2 minus 2 is equal to 0, so we get 10 to the 0th power. And now we understand Why is the first digit 10 to the 0th power? Why is any number to the 0th power equal to 1? Because it has to be. To conclude, in this section we learned about number systems, specifically the decimal number system, a base 10 number system. In the next section we're going to learn about two more number systems, the two that are the most important when it comes to coding. They are the binary and hexadecimal number systems. Here's a spoiler, binary is base 2 and hexadecimal is base 16.